Section 1.5, Evaluating Expressions. So first off, when we talk about an algebraic expression, what all that means is when we're using variables, numbers, and operations and combining them together. A lot of times when we talk about algebraic expressions, we'll really just use the word expression. So if you hear me say expression, I'm talking about an algebraic expression. So first thing we're going to do is, given these values, we're just going to practice evaluating these expressions, and all that means is plugging in these values for all these variables. So this first one, it's a, which is -1, times b, which is 5, minus c, which is 2. And I do highly recommend using parentheses around every variable, because sometimes with negatives it can get a little bit confusing. So notice this minus is here. Even though c is a positive number, we still have to subtract that positive number. And now we simplify with order of operations. -5 minus 2, -7. Remember, we can do plus and negative if that helps. So now the second one, a to the c power. So a to that c power plus 7 times b times c. -1 times -1 is 1. 7 times 5 is 35 times 2, so 1 plus 35 times 2 is 70. 70 plus 1, 71. Last but not least, our numerators, a, b, c. So -1 times 5 times 2. Denominator is b, so 5 plus c, which is 2. -1 times 5 is -5, times 2 is -10. 5 plus 2 is 7. See, that wasn't so hard. Now this next part, your book does list several area formulas as well as volume formulas. I am not going to rewrite those here on your notes because they are listed in the book. So I highly recommend either you copy them into your notes or you somehow mark your book to indicate that these are very important, because you are expected to know these. They will not be given to you on a test. The other key thing I want to point out, area, your units should always be squared at the end. So if you're doing anything with area, your units is units squared or square units. Volume will always have units cubed or cubed units. Area is 2 dimensions, so it's exponent of 2. Volume is 3 dimensions, so your units have an exponent of 3. So we're going to determine the area of these two different shapes. So the first one, we have a rectangle. It's got a base of 5 and a height of 12. Area is length times width. So in our case, 5 meters by 12 meters. Multiplying them together, we get 60 meters squared. So this is what I was talking about with units. We have a unit squared there, and it makes sense because we're finding the area right now. Alright, next up, we're finding a triangle, the area of a triangle, with a height of 4 and a base of 10. Notice they're both centimeters, so we're good there. Our area is 1/2 the base times the height. Half of 10 centimeters is 5 centimeters. We still have times 4 centimeters. 5 times 4 is 20. Centimeters times centimeters is centimeters squared. So once again, that unit is squared, which is what we want. Alright, next up we've got a circle with a diameter of 16. Now remember, for our circle, it's pi r squared. We need the radius. So the radius is half of that diameter. So half of 16 is 8. We still need our unit of yards. Pi we're going to leave. 8 squared, 64 yards squared is yards squared. And you can leave your answer as 64 pi yards squared. You don't have to multiply 64 times 3.14. So now we're going to practice with volume. So the first one, we've got a sphere, and we know the radius is 2 feet. The volume for a sphere is 4/3 pi r cubed. So our radius is 2 cubed, 2 feet cubed. 2 cubed is 8. 4/3 times 8. You can put this 8 over 1. 4 times 8 is 32 over 3 pi feet cubed. And you can leave your answer like this for this class. Right, if we've got a cylinder, we've got a diameter of 10 and a height of 4. So I obviously did not draw this to scale, but that's okay. The volume is area of the base. So when we have a big B, this is area of the base. And the base is just, there should be two sides that are the same that you could rest it on. Think of it in terms like if you were going to set it on a desk, which side would you place down? In this case, it's a circle. So instead of B, we do the area of a circle, pi r squared, times our height. So pi times our radius. Remember, our diameter was 10, so our radius is 5 inches squared, times our height of 4 inches. Four times 25 is 100. We can leave our pi and then inches cubed, because inches squared times inches gives us our inches cubed. So next up, we've got a rectangular prism with a length of 3, height of 6, and a width of 4. This should be width right here. Once again, volume is area of that base times the height. And it doesn't necessarily even matter in this case which one you'd make the base. But I'm going to go ahead and say that this end down here is your base, which would have a second base up here. Remember, since it's a rectangle, it's length times width. Four times 3 is 12. 12 times 6 is 72. Yard times yard times yard would give us yard cubed. Alright, so now we've got a cone with a radius of 12 meters. So volume for cones is 1/3 area of that base times the height. One thing I forgot to add in here, it's got a height of 7 meters. So 1/3 the area of the base times the height. Once again, this area of the base is a circle, so it's pi r squared times our height. (12 squared is 144, meters squared is meters squared. 1/3 of 144 is 48. We still have this times our 7 meters. 48 times 7 is 336. We still have our pi, and now it's meters cubed from this meters squared with that meter. Last one on this page, a pyramid with a rectangular base. We've got 6 inches by 5 inches and a height of 10 inches. So it's still 1/3 our area of the base times the height. In this case, our base is a rectangle. One-third of 6 is 2. And then we still have inches times 5 inches times 10 inches. 2 times 5 is 10. 10 times 10 is 100. And inches cubed, because it's inches, inches, inches.